And good morning, fourth grade students of room 502. Got a lot to do today with our Eureka math. And what does Eureka mean in English? It's a Latin phrase. What does it mean in English? It means I have found it. And what have we found? We found the best way to learn math. You're gonna need a couple of things before we get started. Get out your homework, page 27. You're going to have your math packet with lesson 15 on it. And also on your desk are two blank pieces of paper that we're going to be folding fun. Let's get started right away with our homework. And remember, we're just multiplying by 4, right? There's 4, 8, 12, 13, 14, 15, 16, 20, 24, 28, 32, 36, and 40. So that was what our homework was. Then we had to do the matching lines. I'm going to check my zoom in and zoom out here. Let's go out a little bit. I think we can see that pretty good, can't we, kids? Here we can. Well, a little more. Okay, so we have 4 times 1 right here. 8 is 4 times 2, or 2 times 4. 12, what would it be? Well, if you were thinking 4 times 3 or 3 times 4, you're absolutely correct. We have 16 is 4 times 4. 20, 4 times 5. 24 is 4 times 6, or 6 times 4. 28, we're looking for that 7. 7 times 4 on the 28. 32, 8 times 4 is 32. 9 times 4, you got it, it is 36 if I can find it. There's the 10 times 4, there's the 9 times 4, and 10 times 4 is 40. Okay, hope you got that. And let's turn it over to the other side. I'm going to grab another piece of homework because I marked that one all up. Let's get to page 28. Of course, I'm probably missing it. There we go. Let's have a little fun with tape diagrams. And we're at problem 2. I'm going to zoom in a little bit on this one. Excuse me. Okay, we've got problem 2 going on. Got to read our directions. Just got to get the right kind of pen. Thank you for being so patient. You're the most patient group of 3rd graders I've ever met. Okay, it says Lisa places 5 rows of 4 juice boxes in the refrigerator. Draw an array and skip count to find out the total number of juice boxes, not juke boxes. Okay, 5 rows, 4 juice boxes. Let's see how that looks like. We know the number of rows, right? 5 rows. Okay, let's see what we got going here. We're going to do 1, 2, 3, 4, and 5 rows. We know the number of juice boxes in each row, and I'm going to put 4 JBs for juice boxes. And I'll go 1, 2, 3, 4. What the big question mark is, how many boxes? Okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we had 4 there, so 4, 8, 12, 16, 20, and there are 20 juice boxes in total. We'll go up here to number 3. I just gotta check my, yeah, I'm doing okay. So we have 6 folders are placed on each table. How many folders are there on 4 tables? It says to draw and label a tape diagram to solve. So we have 6 folders are placed on each table, and how many folders are there on 4 tables? So we know the number of folders. The number of tables. There's our bracket. 4 tables. 1, 2, 3, and 4. We know there's 6 folders placed on each table, so I'm just going to put 6F. And that F stands for folders. Let's go ahead and put 6 on each. Okay, so 6 there. Let's skip count to find out what we got going here. We got 6, 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So what we didn't know were the number of folders altogether. So we can now write. It says, we'll say there are 24 folders on 4 tables. Going kind of fast because we've got a lot to get through. Let's go to the very last one. It says find the total number of corners on 8 squares. When we think about a square, 1, 2, 3, 4, there's 4 corners. So let's make a tape diagram. And let's make 8 squares. 1, 2, 3, 4, 5, 6, 7, and 8. We know that there's 4 corners on each side, so I'll put on each square, I'll put 4 corners. We know that there are 8 squares, man. 8 squares. What we don't know are the number of corners. All right? So let's skip count. 4, 8, 12, 16, 20, 24, 28, and 32. So we say 8 times 4 is 32, and we can write this down as there are 32 corners. Period. Go ahead and pause the video and put this in the blue bin. Oh, your homework? No, we got a new homework drawer that I told you about. Hope I remember to tell you about. So that's where our homework's going to go from now on, okay? Let's get out our packet. It's a mini packet, just 2 pages on each side. And we're going to read our objective today. It's going to be to relate arrays to tape diagrams to model the commutative property of multiplication. What was the commutative property, Mr. Leggett? Well, we're going to review that, okay? So don't worry, we'll review the commutative property. So for starters, let's start reviewing multiplying by 4. And I'm going to zoom out a little bit for you. There we go. Hopefully we're all working out here. And I'll write real big so we can see. Our first problem is 5 times 4. What does that equal? Some of you know that off the top of your head. But let's do a little skip counting. Are you ready with me? 4, 8, 12, 16, 20. That'd be 5 4s is 20. So we're going to put our 20 right there. And we'll write... circle that 20. There we go. And now let's write something else. Let's do 4 times 4. What does that equal? We can skip count on that one again. 4, 8, 12, 16. No, it's 16. We had 4, 8, 12, 16. And if we went backwards, we could have just gone, 4, 8, 12, 16, 20, 24, 20, up 16. And let's find... the 3 times 4, and here we go, 3 times 4. What's that could equal? We can go backwards on this one again. Look, 5 is 20, 4 times 4 is 16, so 3 times 4 is what? Think about it going backwards. Okay, 4, 8, 12, 16, so 12 was before the 4 times 4, and we're going to put a 12 right here. So now we're going to practice multiplying by 4. So you're going to be getting this wonderful sheet, and it's called the Lesson 15 Pattern Sheet. One of my favorite pattern sheets of all time. And so think about it. You're going to be doing some skip counting. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. I want you to pause the video and fill this whole section out. Don't even go on until it's completely done. Got it? Thank you. So that's what we're doing. Pause tape, finish. Okie dokery. Welcome back to part 2 of the Eureka math lesson. And this is the application problem. It's a problem we can apply to real life. I don't know if you would ever do this in real life, but let's just pretend we would. It says a cell phone is about 4 inches long. That's something we do know. What we need to find out is about how long are 9 cell phones laid end to end. I'm going to circle that number 9. So we know that 4 and 9 are going to be part of this application problem if we plan on figuring it out, okay, which we plan on doing. So what's my tape diagram going to look like? Well, when we do a tape diagram, we go with the things that we know. Okay, what's something we know here? We know there's 9 cell phones, so let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many inches are each cell phone? Oh, I'm sorry. Bracket time. 9 cell phones. And we know how many inches each one is. 4, right? So I'm going to put 4. Let's just do the inch symbol like that. That means inches. So we have 9 cell phones, 4 inches each. What we don't know is how many inches all these cell phones are, one after another. So we could take this and we can go 4 times what? Well, 4 times 9, right? And if we were in real dire straits, and we don't know what 4 times 9 is over our, on top of our head, we could always skip count, right? 4, 8, 12, 16, 20, 24, 28, 32, 36. Or we could go, okay, I'm going to put 4 place value, not place value disk, counting disk in here, counting dots. 4 each, and then we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we got 36 of these inches to show that not 4 times 9 equals 36. Time to do a little writing. 9 cell phones are about, we're not know exact because we said about 4 inches, are about 36 inches long. So we got 9 cell phones are roughly 36 inches long. Okay, so that is our application problem. Whoops, I'll go back to it. You can remember, you can pause this if you need to write it down. Get ready to do some folding. Here we go. Take one of your pieces of blank paper, put this in the blue bin. Worksheets and stuff go in the blue bin. So we got a piece of folded paper, or a piece of paper. We're going to do a little folding. Okay, so the first thing we're going to do is what is the first thing we're going to do? Okay, so we're going to make a dotted line right around here, about 1/3 of the paper. Got that? Got it? Good. So what we're going to do is we're going to make an array up top. An array like this. Let's get out the, I'll do this. All right, so that's what we got going so far. Got it? And let's do some, I believe we're going to do a tape diagram beneath this. And let's go ahead. Well, you know what we're going to do right now? I'm sorry. We're going to fold right along here. Just do your best. It doesn't have to be perfect. I'm not submitting it to the Smithsonian Institute. So just a little fold right there. And now let's do a tape diagram. We're going to say 2 times 4 equals 8. And here's the commutative property. And that's 4 times 2 equals 8. Look, we flip-flopped them, and it still equals 8. Well, Mr. Liggett, I need you to prove that to me because I just can't understand that. Well, a great way to prove things is the old tape diagrammy. So let's go ahead and do the tape diagrammy. And we'll go like this, 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 and that. Now, we have 2 times 4. So what we're going to do here is we're going to equal 8. So we don't have to have 8 units right there. Let's split it in half to show 2 times, and it's 2 times 4. Bracket up top. What are we gonna get? We're gonna get 8. Don't believe me? No, we don't believe you. Well, let's double check that. 2 times 4. There's 1 4 coming at you. There's 2 4s coming at you. And look at that. It is 1, 2, 3, 4, 5, 6, 7, 8. Let's go to 4 times 2. Okay, let's go to 4 times 2. See if it actually works, okay? So I'm going to go right like this. I'm going to make it kind of the same size to show you that there's no trickery or magic involved. And we're doing 4 times 2. Well, I know that this here, partners, is going to equal 8. And we're going to break it up into 4 pieces, right? Because it's 4 times 2. 1, 2, and 3, and 4. There we have it. So now up here, instead of a 4, we're going to put the number 2. So does 4 times 2 equal 8, as 2 times 4 does? Let's figure this out and see if it actually pertains to be true. Here we go. We'll go 1, 2, 3, 4, 5, 6, 7, 8. It is magic. And when you look at it like this, why, it makes perfect sense. We can see that 2 times 4 equals 8, but then we can go 4 times 2 equals 8 as well. Ladies and gentlemen, this is the commutative property at its finest. And I think you'll be very happy as we delve further and further into the commutative property. Let's get our next piece of paper out there, boys and girls. And we're going to make that same dotted line. Use the blue pen. And we're going to go dee, 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 skipping to grandma's house. Okay, now, once we're done there, we can fold right around here. It doesn't have to be perfect. I'm not sending this to the Los Angeles County Museum of Art, LACMA as it's called. And let's get going on another multiplication problem. Oh, this is a big one. So we have to pay very close attention. Very close attention indeed. Let's see what we go. We're going to do this. Get ready for this. We're going to go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. How many groups of 4 do I have? 1, 2, 3, 4, 5, 6. I want more! There's 7. There's 8. And I have an outstanding 9 groups of 4. Go ahead and do this with me. There's 1 group of 4. You don't have to color them in. I'm just biding time as you catch up. Here comes 3 groups of 4. 4 groups of 4. 5 groups of 4. 6 groups of 4. And 7 groups of 4. And 8 groups of 4. Finally, we get to 9 groups of 4. There we have it, 9 groups of 4. It means 9 times 4, is that right? You better believe that's correct. So let's go ahead and figure out what 9 times 4 is before we make another move. Okay, so we're going to go 9 times 4. We'll go 9 times 4. We're going to go over to the left here a little bit so we have room to deal with our tape diagrams. You know how much room them tape diagrams can take up. We do 9 times 4, and we're also going to do 4 times 9. Once again, over to the left, to the left, to the left, left, left. And we're going to figure this all out. Let's do 9 times 4 first. And here comes our extra long tape diagram. Well, first of all, we have to know what 9 times 4 is so we can do the bracket properly. And doing a bracket properly is very important. If you don't do the bracket properly, who knows what might happen. Now, there's a couple of ways we can do this. Some of us, right off the top of our heads, know what 9 times 4 is, right? Some of us can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Some of us can do it that way. Some of us might say, okay, well, I know it's 9 times 4, so I'm going to break this up into 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then once I've broken it into 9 pieces, and I know this tiny bracket is going to equal 4, then I can do a little bit of what I call skip counting. 4, 8, 12, 16, 20, 24, 28, 32, and 36. Looks like it's 36. We counted 36 there. If we wanted to waste some time, and why not, let's just go ahead and go like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. It's not really wasting time. It's giving me a visual representation of 9 times 4. Because in Eureka Math, we get it. We don't just remember things. We say, I know why 9 times 4 is 9 times 4, and I can draw an array, and I can draw a tape diagram, and I can show you 3 times to the moon how what 9 times 4 equals 36. Now let's go down to our friend 4 times 9. Let's see what happens with him. And this is part of the commutative property. Okay, so we know, oops, 36. Almost missed that. So our bracket here is 36. We know it's 36 because we know the commutative property works perfectly. We know that 9 times 4 will have the same answer as 4 times 9. It's gonna be 36, kids. And we'll show you how it's done. Well, this is 4 times 9, so I'm gonna break it into 4 pieces. 1, 2, 3, and 4. And how many will reside in each piece? If you said 9, you are on the right track to respecting and knowing the commutative property. Now, let's just go ahead for fun, and we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18. 19, 20, 21, 22, 23, oops. 18, 19, 20, 21, goodbye, 22, 23, 24, 25, 26, 27. 28, 29, 30, 31, 32, 33, 34, 35, 36 is the answer. We got 4 times 9 is indeed 36. There's no doubt about it. We have proven that the commutative property works perfectly. You can flip those numbers around, and by golly, they will still work. Go ahead and try something different. You won't find anything different. It's going to work that way all the time, every day. Now, I'm going to do this, but you're just going to kind of take a look at it. See, okay? Okay? Let's just do 2 examples here, and we're going to do an array of this 5 times 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. You don't need to do this with me. But Mr. Lincoln, I'm out of room. I know you're out of room. It's okay. So we have an array of 5 times 4. Okay. So let's go ahead and write it up here. 5 times 4. Now, what I want you to think about is we're going to do another equation. What else could we do? We have 5 times 4. What if I were to do this? Lock it into place. What would that be? This would be, look, 4 columns. 4 columns. And how many? 5. So it would be 4 times 5. Once again, the commutative property proves that it's a valuable thing by showing us, once again, that this works. Look. 5 times 4, that's 4 5 times, or 5 4 times. Voila! Let's continue going with another example. And this is always a tough one for some people. We're going to do 4 times 7. Okay, we're going to do 4 times 7. 1, 2, 3, 4, 5, 6, 7. There's 1 times 7. 1, 2, 3, 4, 5, 6, 7. That's 2 times 7. 1, 2, 3, 4, 5, 6, 7. That's 3 times 7. And 1, 2, 3, 4, 5, 6, 7. That's 4 times 7. What does that equal? Well, if we can count by 4s, when we go this way, 4, 8, 12, 16, 20, 24, 27. But now, let's watch the commutative property in action. Oh, look, it's the calculating cat. He wants to help out. Do you want to turn this around, calculating cat? Do you want to help us? Okay, you could give it your best shot, calculating cat. Oh, you're doing a fine job. You really are starting to learn and love math. Oh, calculating cat. Great job. No, keep it on the paper, calculating cat. Keep it on. Get away, cat. Okay, get rid of calculating cat. He always starts out strong, but then he always wants to goof off. So we have rows of 4 here. How many rows of 4? 1, 2, 3, 4, 5, 6, 7. So this time around, it'd be 7 times 4. 7 rows of 4 equals 28 too. Ladies and gentlemen, behold the glory that is the commutative property. Okay, we're going to continue on with our ParabolaFET. Will that be a problem? Oh no, Mr. Leggett, no problem at all. Fantastic. Okay, so what you're going to go to is page 35. And let's get right down to it. Page 35. Today's date, it's actually the 9th. I'm still here at night. But tomorrow will be the 10th. Yes. It says, label the tape diagrams and complete the equations. Then draw an array to represent the problem. Well, some of this is done for us, as we can see. So let's take a look at our ants. Ants. He's got ants in his pants, as they said. Okay, so 2 times 4. 1, 2, 3, 4, 5, 6, 7, 8. We know that there's 4 ants. I crossed that out a little bit, but there's 4 ants in each row. So there's an 8. And then what number do we put down here? We're also going to put down an 8. 1, 2, 3, 4, 5, 6, 7, 8. Now look what they've done here. Same thing. 4 times 2. What is 4 times 2? Why, it's 8. And look, we have 2 ants here. 2, 4, 6, 8. And there's 8 ants total. So that's how you do this side. I want you to do it on your own. Let's flip it on over. Oh, flip it on over with me so you know what to do on the back side. Here we go. It says, draw and label 2 tape diagrams to model the statement that the box is true. It's saying 4 times 6 equals 6 times 4. So what you would do, let's just do a little review. Tape diagram. Remember, you're going to have to do 2 of these. And you're going to prove to me if this is true or not. 4 times 6 equals 6 times 4. And how you're going to do that. Remember, we know that 6 times 4, because we can skip count, 4, 8, 12, 16, 20, 24, is going to be 24. We do know that. So both of these would have to equal 24 if we can do it. And then, of course, we would go, we break this one up, 4 times 6. We break it up into 4 parts, 1, 2, 3, and 4. And this one is 6 times 4, 1, 2, 3, 4, 5, and 6. I want you to go ahead and prove the rest. Remember to make your little tiny bracket here and a little tiny bracket there. Go ahead and pause on that if you need to set up the problem. I'm going to go on to problem 3. It says, Grace picks 4 flowers from her garden. This is what we know, 4 flowers. Each flower has 8 petals. Draw and label a tape diagram to show how many petals there are in total. Remember, the beauty of the tape diagram, it tells us what we know and what we don't know. What we do know is that there are 4 flowers. 1, 2, 3, and 4. 4 flowers. How many petals are in each flower? 8. Tiny little bracket. And I'm going to put 8P for 8 petals. You figure out the rest. Remember to write, there are blank petals on the flowers. And go ahead and pause that one up if you need to. Finally, I'm going to help you out set up number 8 just a little bit. You can say Michael counts 8 chairs in his dining room, circle the 8. Each chair has 4 legs. Well, that's convenient. How many chair legs are there altogether? Oh, that Michael, he's always up to counting stuff. So once again, you're going to use a tape diagram to show this. And remember, get that tape diagram going. And this is all I'm going to give you. You're getting a number there. You're getting a number by the little tiny bracket. You're going to have to split that up. You're going to have to give me an answer. All right, good luck on this. We'll be doing our student debrief and exit ticket later on today. Thank you for being a wonderful audience, 4th grade students. I hope the tape made it all the way through. Just about to die on me. Only 1 minute to go.